In this video, we're going to be going over the basics of inferential statistics. So basically, I just want to kind of review a little bit about the overall inferential framework. Right, so first, in general, we start by assuming that there's no difference or no change or no relationship. Essentially, what we're trying to do is kind of set up a hypothesis, and then it's our job to basically disprove that hypothesis. Right? So to disprove that, what we have to do is we try to find the probability that we observe our sample given that this initial assumption is true. If this probability is low, then the assumption is probably not true, and there is a relationship. Right? So we're trying to basically set this up so we say, first, assume there's no relationship, look at our data. If our data, basically doesn't support that assumption, then we're going to have to reject that assumption. Alright, so basically, there's kind of two ways of doing inferential statistics that we're going to be going over in this course, hypothesis tests and confidence intervals. Obviously, inferential statistics kind of is a very big area and kind of spans more than just kind of these groups, but this is what we're going to be covering. So we'll be doing hypothesis tests and confidence intervals. In this video, I'm only going to be really talking about hypothesis tests. Alright, so basically for hypothesis tests, we've actually kind of done some of these informal hypothesis tests before. We use simulations to basically look at what this distribution would look like, this empirical distribution would look like, and then we kind of assessed whether, for example, a die was fair or a coin was fair. And now we're basically just going to be formalizing that entire process. Alright, so there's four main steps. Formulate the hypotheses, prepare. So this is, for example, depending on what kind of test you're doing, you might have to check certain conditions, and you might want to set the alpha level. And then calculate test statistics. So depending on, again, what you are testing, you're going to have to maybe calculate some different statistics based on the data. And then you have to interpret results. Alright, so formulating hypotheses. Basically, we state two hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis is what we were talking about, that kind of no change baseline level. Basically, we're just saying, there's no difference. The alternative hypothesis is that there is some sort of change or relationship or difference. And so we typically denote these with H0 and HA. So, in general, the alternative hypothesis can be one-sided or two-sided. Basically, this really just kind of affects what we're interested in finding out. So, for example, if a certain candidate will get more than 50% of votes, we might use a one-sided test. We might use a two-sided test if you just want to know if there's a difference, not that one is greater than the other. So, example of hypotheses, well, basically, it's just kind of if, for example, a mean is equal to 0 or a mean is not equal to 0. Or, for example, if we want to find out if the proportion is equal to 0.5 or if it's greater than 0.5. If we want to know basically if a certain proposition will pass, and so we want to know if it's going to be greater than 0.5. One big thing to note is that these are always about the population. Remember, the population is something that we don't know something about. That's why we collect our sample, and we want to basically make inferences about the population based on our sample. And so we know that our sample is random, and so we might not exactly know just kind of how exactly close to the population it is. And so that's why we're using this kind of formal inference. We're trying to see what kind of conclusions we can make about the population based on our sample. And so also remember, this is hypothesis testing for a reason. So any conclusion must be based on these hypotheses. So, remember what we're trying to do is disprove our null hypothesis. Every conclusion that we make will be based on that process. And so you can't kind of extend out further than that. And it might be really tempting to do so, but you have to make sure to basically base your conclusions on that null hypothesis. The alpha level, now moving on to the second step, is just kind of how certain we need to be in order to reject the null hypothesis. So basically, if let's say there's a 2% chance that you get your sample if the null hypothesis is true. Now, is that unlikely enough? I mean, it seems pretty unlikely, right? So if there's only a 2% chance that we observe a sample, then our null hypothesis probably isn't true. It's probably something different. Remember, we're assuming the null hypothesis is true, and then trying to see how likely our data, our sample are. So basically, this is just kind of this, very arbitrary number. The default that a lot of people use is 5%, 0.05. You don't have to use 0.05. There's nothing really special about that number. It just happens to be the default that people kind of tend towards. Basically the number we choose to kind of set that level is just kind of, thinking about the definition is just kind of thinking about, how unlikely does it have to be? Do we want to really be sure before we reject our null hypothesis? Or, is it okay if we maybe, don't really worry too much about, if we incorrectly reject the null hypothesis? All right. And so then after that, you kind of calculate your test statistic. And we'll do that using simulations. And, really there's, depending on the situation, there's all sorts of different test statistics that we might use. But really the idea behind this is that, this is what we're going to be using to evaluate how unlikely our sample is. And so we're going to be using that simulation to kind of build up that empirical distribution. And then we'll kind of see, how likely is it that we get that sample that we observed, that one sample that we observed within this overall empirical distribution. All right, and then now after this, you have to make your decision. So basically, again, this is always based on our hypotheses. And basically, you need to either reject or fail to reject the null hypothesis. And a lot of times what we do is we find the p-value. The p-value being that exact probability that we observe a sample statistic as extreme or more extreme than what we observed. In our case, we won't necessarily, have to find that exact p-value because we're going to be using simulations in order to be testing this. But this is really the concept that we're trying to get at. We're trying to see how likely is it that we observe that sample statistic if the null hypothesis were true. Right. So basically, this is kind of an example of the p-value, the shaded area representing the p-value, and here what we have is a two-sided test, and so even though our test statistic is on one side, we also look at that right side. The observations are just as unlikely on the high side if it's far away enough. So basically, we just kind of essentially double the value. So we look at what's further away from the null hypothesis mean, on the left side, and then over on the right side as well. All right. So basically, what we're going to do is we're going to look at our p-value and say if that p-value is low enough, if it's less than our alpha level, then we reject the null hypothesis. If the p-value is greater than the alpha level, then we're going to fail to reject the null hypothesis.